You know, our senses of taste and smell, they feel kind of magical, right? Like, what exactly makes something sweet? Or what gives a perfume that specific scent? It seems almost impossible to put into words. But what if we could teach a computer to speak the language of flavor? Well, that's exactly what's happening. Let's get into how AI is pulling this off.
I mean, seriously, just imagine this for a second. Could a computer look at a bunch of code representing a molecule and know, right then and there, that you're going to hate the new soda they're about to make before a single person has even tasted it? It sounds like something straight out of a sci-fi movie. But believe it or not, we are getting unbelievably close.
All right, so let's talk about the mystery of our senses. Why is predicting flavor so incredibly hard? Well, it's not just about, whether you like strawberries and I don't. It goes way deeper than that. We're talking about a super complex puzzle of molecular chemistry. And trying to solve it the old way, man, it was slow, crazy expensive, and honestly, a bit of a mess. So first, let's get into the biology of it all.
Okay, so this really breaks it down. We're looking at how we sense the world, and right away you see the big difference between taste and smell. For taste, a molecule from your food has to literally bump into a specific receptor on your tongue. It's direct contact. But for smell, it's a whole different game. A molecule has to go airborne, float all the way up into your nose, and find its matching receptor there. So you've got these two totally separate biological pathways, and that means you've got two totally different problems for an AI to crack. And for forever, the old solution was, let's be honest, kind of clumsy. You'd get a bunch of people together in a room for these taste test panels. Sip this, sniff that, what do you think? It was pure trial and error. So slow, super expensive, and worst of all, it's completely subjective. What one person loves, another hates. There just had to be a better, smarter way to do this.
And that brings us to our first major breakthrough, an AI that can actually taste. We're talking about a brand new technological tool built from the ground up to translate molecules into flavor. Researchers have put together this really incredible AI that's all about decoding the language of taste. And yeah, they gave it a pretty memorable name. It's called FART. That stands for Flavor Analysis and Recognition Transformer. But the name isn't the important part. What's key is this idea of a chemical language model. So get this, instead of seeing a molecule as some complex 3D shape, the AI sees it as a line of text, like a sentence, and its job is to read that chemical sentence and basically translate it for us into a taste, like sweet or bitter. So how does FART actually predict taste? Well, the process is surprisingly straightforward. First, scientists take a molecule and represent it as a simple text string. It's called a smile string. They feed that string into the AI. Now, this AI has already been trained on millions of other chemical sentences, so it knows what to look for. And then step 3, it just spits out a prediction. Sweet, bitter, sour, or umami. That's it.
Okay, but the big question is, does it actually work?
Oh, yes. We're talking over 91% accuracy. Let that sink in. Over 91%. That's not just good. That is a stunning level of success. It's just leagues beyond what those old-school taste panels could ever hope to achieve. But here's what I think is the real game changer. This thing isn't some mysterious black box where you put data in and an answer comes out. No way. The AI can actually show its work. It can point to the exact atoms in the molecule and say, see this part right here? This is what's making it taste bitter. For scientists trying to create a new flavor, that's like being handed the keys to the kingdom. It's a complete roadmap.
Okay, so that's the AI that can taste. Pretty cool, right? But now we're going to pivot to an AI that can smell. And this is where things get even more complicated. The challenge of smell, it's a whole different beast, because we're not just talking about single molecules anymore. We're talking about complex blends.
Yeah, think about it. The smell of your morning coffee or your favorite perfume, that's not just one single molecule doing all the work. It's a complex chord, a mixture of dozens, sometimes hundreds of different molecules all working together. And here's the tricky part. When you mix them, their smells don't just add up. 1 + 1 does not equal 2. They interact in all these weird, totally unpredictable ways. And this is where the science of scent blends gets just plain weird. You've got two things happening. First, there's something called emergence. That's when you mix a couple of molecules and a totally new, completely unexpected smell, like cabbage or eggy, just pops into existence, out of nowhere. Then you have the opposite, suppression. This is where a lovely smell you are going for, like peach, can just vanish. It gets totally wiped out by another molecule in the mix. The big takeaway here is that the final scent is rarely, if ever, just the sum of its parts. So here we are, back to our core idea.
Two very different biological problems demand two very different AI solutions. On one hand, for taste, you have the FART model. It's text-based and it's fantastic for analyzing single molecules one at a time. But for smell, with all those crazy interactions, you need something different. Scientists needed a graph-based model, something that could actually map out and understand the complex relationships between all the different molecules in a blend.
And that tool is called a graph neural network, or a GNN. Now, this AI doesn't see a line of text. It sees the molecule as what it is, a network of interconnected atoms. The analogy of a social network for atoms is perfect. A GNN doesn't just care about one atom on its own. It cares about who that atom is connected to, what those relationships are like, and how all those connections together create the final effect, the final scent. Now, if you're going to teach an AI something this complicated, you need data, a lot of data. We're talking over 160,000 labeled data points of molecule pairs. The team had to build this massive dataset from scratch, and it's now the largest public dataset of its kind in the world. Just an enormous undertaking.
And did all that work pay off? Just look at this chart. That bar on the far left shows the GNN model's performance. Now that score, AUROC, all you need to know is that 0.5 is basically a random guess, like flipping a coin, and 1.0 would be a perfect score. The GNN clocks in at 0.76. Look how it just blows the baseline model out of the water. It's not just a little better, it's a massive leap forward in our ability to predict smell. Okay, so let's recap. We've talked about the biology of taste and smell. We've looked at the two amazing technological tools AI has given us to understand them. Now for the really fun part, the future of flavor. How is this stuff actually going to change our world? What are the applications?
Honestly, the real-world applications here are just huge. On the taste side, think about discovering brand new sweeteners that are actually good for you. Or imagine making essential medicines less bitter so they're easier for kids or anyone to take. Then, for smell, you could design the next iconic perfume without all that endless manual trial and error. And for the companies making our food and drinks, this means they can quickly figure out what's valuable in natural foods, and maybe most importantly, they can avoid those nasty cabbage surprises when they're developing a new product. You know, the researchers who built the Taste AI said it perfectly. They said artificial intelligence has a role in assisting the food scientist of tomorrow. And that really is the key, isn't it? This isn't about AI replacing chefs or scientists. It's about giving them these incredible new tools to work faster, smarter, and discover things they never could before.
And you've got to understand, this isn't just happening in some isolated university lab. This progress is being absolutely supercharged because you've got the brilliant academic researchers working hand in hand with innovative food and fragrance companies. It's that synergy, the science and the industry coming together, that's turning all this amazing research into products we'll actually see on the shelves.
So all of this leaves us with one last big question to chew on. If an AI can not only understand but actually design a perfect flavor or a breathtaking scent completely from scratch, what does that mean for human creativity? At what point does a tool become a creator in its own right, and what does that mean for the future art of the chef, the flavorist, or the perfumer? It's definitely something to think about.